typically all measured quantities, whether it's inches or grams or time, there is uncertainty in all measured quantities. And the way we show uncertainty, or when somebody gives you a quantity, the last digit to the right is where the uncertainty begins. So a minute ago I said something like 2.5 pounds or 2.5 grams. The uncertainty begins right here, or the uncertainty is right there in that, in the, what we say, the tenths places. So the uncertainty is always in the last digit. I can show that by, for instance, let's just go ahead and we'll call this centimeters. Okay, so 4.1267 centimeters. Now, we say that there is uncertainty, and I'll make it red hot, in that 7 in the 0.0001 area. That's where there is uncertainty. These first digits we say are exact. We know this for sure. There's no uncertainty here. This is exact. And the last digit, that's where the play is. Here we see somebody measuring mass, and one of the things we're going to be doing in lab, our measurements lab, is we are going to actually force ourselves to measure between gradations, estimate, I should say, between gradations. I don't know if you buy this, but to me that looks like, and to the person that looks like about 2/10 of the way between those gradations. So that's why this is 1.2 grams. Okay, so the last digit is what we say uncertain. Sometimes when I try to show uncertainty, I show it red hot, I'll put like a little question mark there. That's where the uncertainty is. The 1 is exact in the 1's place, and the 0.2, there's uncertainty. This is another sort of balance. They're measuring the mass of a pistachio. Is that not cool or what? And here we have we know it's at least 1 gram. Oops, let me go back. We know it's at least 1 gram because the dial is past the 1. This would be 0.5 and this would be to 2. So each of these places is the tenths. So we have, looks like it goes past 2/10 and on its way to the 3/10. So it's 1.2, and what they went ahead and went with is about 6 parts between those last gradations. It might be hard for you to see, but that's why it's 1.26. The units are grams. So here the 6 there in the would be what the hundredths place, there's uncertainty, and the 1 and the 2 digit is known for sure. So anytime we have a measured quantity, the last digit is where the uncertainty lies. Come on. Go to the next slide. Okay, there we go. I might have mentioned a minute ago, all measured quantities have uncertainty associated with them. There are 2 types of measured quantities where there is no uncertainty. And we call that number, and it has an exact value. For instance, of the 2 types, here's one. If you actually count something, measured quantities that came from counting, that actually is an exact number. So if you're in a classroom with 13 people, we will say there are 13 people in that classroom. Okay, we would not say there's 13 with that digit there in the 1's place being uncertain. There's not like 13 plus or minus 1. No, there are exactly 13 people because we got that by counting. The other one, exact number, and I have some examples coming up, is by definition. So, for instance, the metric system is a great example of this exact relationship. We would say that kilo means 1,000 times the base unit. So if we have 1 kilometer, we have exactly 1,000 meters. Okay, so that is an exact relationship. That is by definition what a kilo means. So there's no uncertainty there. So the cool thing about exact numbers is that if we are, well, there's a lot of cool things, but one of the things is when we start to do calculations, if we have a number that's an exact number, then that brings what we call, adds no additional uncertainty to the calculation. Here's an example. Instead of people, here we have what, 7 coins? So there's exactly 7 coins. It's not, oh, there's like either 6 to 8. No, there's exactly 7. And here's another example by definition. There are a few English relationships that I'm going to hold you accountable for. Remember, I can use an equal sign. This is going to be an equivalency statement. If I would say 1 foot is equal to blank inches, hopefully you would tell me 12. 1 foot is, we say, equal to 12 inches. This is an exact relationship. So sometimes we'll say 1 foot is exactly equal to 12 inches, and that is actually by definition. By definition. What do I mean by definition? Well, when they set up this English system, that's the way it is.